So when we're multiplying and dividing rational expressions, we use the same rules as multiplying and dividing fractions. The only difference is we have to consider excluded values and things like that. So I'll do the first few examples just to refresh our rules for fractions, and then we'll look at some examples with variables. When we multiply fractions, we always multiply the numerators together and multiply the denominators together. So this would end up being 2 over 12. And we should always simplify fractions as much as possible. So we end up with 1 over 6 in this case. So pause the video and try the one next to it. And so that one simplifies to 5 over 8. So when we divide fractions, we end up multiplying by the reciprocal. And so what I mean is this would become 2/3 times 4 over 1. And when I multiply that, I end up with 8 over 3. So pause the video, try the one on the right. And we see that one simplifies to 5 over 6. So the same thing is true when we're multiplying rational expressions. However, we also shouldn't include any excluded values. So when we look at this equation, we see this expression, we see right away y cannot equal 0. And then we multiply the numerators and denominators together, and we end up with 3x over 12y, and that would simplify as x over 4y. So pause the video and try the one on the right. You see that simplifies to 3y over 2x. Okay, next we have two things we need to include. Now, any value that makes either the numerator or denominator 0 would have to be excluded. And the reason is when we're dividing, if the denominator there is 0, that term is undefined. And if the numerator is 0, then that term is equal to 0. And then we're dividing by 0, which makes the whole thing undefined. So either way, we have to say that x cannot be 0 and y cannot be 0 in this case. And now we're going to get 7x squared over 12x times 48y cubed over 14x cubed. And before multiplying these and getting really large numbers, I might look to start simplifying a bit here. And so I know that 12 goes into 48 4 times, and I know that 7 goes into 14 twice, and then 4 over 2 leaves me with just a 2 in the numerator. So I should end up with something like 2x squared y cubed all over x to the power 5. And I can further simplify the x squared and x to the power 5 and end up with 2y cubed over x cubed. So pause the video and try the one on the right. Okay, we see that one simplifies to 16x to the power 4 over 125. So now we're going to look at examples when we have binomials in the numerator and denominator. And again, we have to include anything that will make it undefined. So we have to say that x cannot equal 2. So now we can multiply the numerator and denominator. We have to distribute it. So we end up with x squared plus x all over 3x minus 6. Oh, pause the video, try the one on the right. Okay, so that one simplifies to 2 minus x over x squared plus 3x. And we just have to make sure we include this statement here that x cannot equal negative 3. Okay, let's continue. Again, we want to include any values that make this undefined right from the start. So we say x cannot equal, in this case there's 3 values, negative 1, 0, and 1. And it's a very good habit to get into, right? But what we see is that this numerator here, this x plus 1, would divide out with this x plus 1. And so we could divide those out to 1, and we don't need to multiply those. And we've taken care of the fact that it is dividing by that by saying that x cannot equal negative 1. So now we're left with 3 in the numerator and x squared minus x in the denominator. Okay, next one. Pause the video and try the one on the right. All right, so we see you get 1 over x plus 3 in this case. If we go down to this next one here, we have a quadratic trinomial and another term that isn't fully factored. So it's always a good idea to fully factor everything before you multiply or divide, because there are oftentimes things will divide out. So this would be 7 times x plus 5. And if I factor this one here, that is a common sum of -3, product of -40, so that's going to be x minus 8, x plus 5, divided by x minus 8. And so from here I can see I can include my excluded values. They are, x cannot be -5 or 8. And I can divide out a lot of these terms because I have an x plus 5 in both numerator and denominator and an x minus 8. And what I'd be left with is x plus 7 over 7 with my 2 excluded values there. So pause the video and try the one on the right. Okay, we see that one simplifies to 3 over 8x squared as long as x is not 0 or 8 over 3. So let's try another one here. This one's going to involve even more factoring. So I'm going to factor everything I can. And so I'm going to take out this 8, and I'm left with x minus 7. And I'm going to take out another 8 from these, and I'm left with x plus 6. And then I factored that, so that's a sum of 9 and a product of 18. So that's x plus 6, x plus 3. And then I will factor out an 8x from here, and I will be left with x plus 3. And then I look at the denominator. I can find my excluded values here. So I say x cannot be 0, -3, or -6. And then now I can start looking for things to divide out. Let's see, 8 and 8 divide out. X plus 3 and x plus 3 divide out. X plus 6 and x plus 6 divide out. And what I end up with is x minus 7 all over 8x, as long as x is not 0, -3, or -6. Okay, pause the video, try the one on the right. Okay, in the end, you should have 3 over 2 times x minus 2, and your excluded values in this situation are -3, 2, and 4.